Welcome to Sleep Monk wherever you are, whatever time it is. I'm glad you've arrived. Tonight we're not chasing answers, we're following a question, one that moves slowly, like the earth itself. It begins not in the stars, but beneath, or feet. What if we're not the first? Not the first to build, not the first to wonder, not the first to leave a mark. It's a quiet question, one that doesn't demand belief, just curiosity. We often think of history as a ladder, each rung a step forward, from fire to farming, from stone to steel, from myth to machine. But the earth doesn't think in ladders, it thinks in layers. Sediment, pressure, heat, time, and time. Here is not measured in lifetimes. It's measured in continents, in oceans that open and close, in mountains that rise and vanish. Human history, as we know it, is a blink. 10,000 years, give or take. Enough to fill libraries, enough to forget most of what came before. But the earth is older, much older, 4.5 billion years. And for most of that time there were no cities, no stories, no humans, just chemistry and change. So if something came before us, something intelligent, something organized, would we even know? Would we recognize the trace? Would we understand the signal? Or would it be gone, erased not by conspiracy, but by geology? Let's pause here, not to answer, just to feel the scale. Imagine a civilization, not mythical, not alien, but terrestrial, biological, native to this planet. It rises, it builds, it thinks, it changes the world in ways we might not recognize, and then it fades, not in fire, not in war, but in time. Millions of years pass. Continents shift, climates swing, sediment buries the surface. And now, here we are, digging, measuring, asking could something have come before? We're used to looking for ruins, walls, tools, bones, but those don't last. Not really. Wood decays, metal rusts, stone erodes, even fossils, our most trusted time capsules, are rare. To fossilize, an organism must be buried quickly, protected from scavengers, preserved by minerals. And even then, it must survive pressure, heat and erosion. Then it must be found. Most life leaves no fossil. Most history leaves no monument. So what does last? Not the structure, but the shift, not the artifact, but the anomaly. When a civilization burns fuel, it changes the air. When it mines metal, it changes the soil. When it farms, it changes the land. These changes, chemical, ecological, planetary, can be written into the earth itself, not as sentences, but as signals. Carbon ratios, isotope spikes, unnatural compounds. They don't tell a story, but they whisper that something happened. And that whisper, if it's loud enough, wide enough, strange enough, might survive. So maybe the question isn't did someone come before, maybe it's would we know if they had. Let's think about scale. Humans have reshaped the planet in just a few centuries. We've altered the atmosphere. We've filled oceans with plastic. We've left radioactive traces in the soil. If we vanish tomorrow, some of those signals would linger, not forever, but long enough to be noticed, long enough to be questioned. Now imagine a civilization that lived not thousands, but millions of years ago. Would its signals survive? Would they be buried, distorted, mistaken for natural change? Would we find them? Would we recognize them? Or would they be filed away as unexplained anomalies? This is where the question deepens, because the earth doesn't preserve evenly. It forgets, it edits, it rewrites. Mountains crumble, seafloors sink, rivers change course, entire regions disappear, and what remains is patchwork, fragment, clue. So if we want to ask whether someone came before, we need to learn how the earth speaks, not in words but in chemistry, in sediment, in silence. We need to listen not for monuments but for disruptions, not for stories but for scars. And we need to accept that most of whatever happened here is gone, not hidden, just undone. Still some things linger, a shift in carbon, a layer of ash, a trace of something synthetic. They don't prove anything, but they suggest. And suggestion, in deep time, is the beginning of wonder. So tonight, we're not chasing proof. We're following possibility. We're asking what the earth might still remember and what it might have already forgotten. We're asking not whether we're alone in the universe, but whether we've ever truly been alone on this planet. And we're doing it slowly, gently, one layer at a time. Chapter 2. The question. Beneath our feet. Let's stay with the question a little longer, not rush past it, not try to solve it. Just let it settle. What if we're not the first? It's a quiet thought, not loud enough to demand belief, but persistent enough to deserve attention. We often imagine ourselves as the beginning, the first spark of intelligence, the first species to build, record, and reflect. But the earth is old, and it has hosted life for billions of years, not just bacteria and fish and ferns, but complexity, variation, possibility. So what if somewhere in that vast stretch of time, another species rose, not like us, but intelligent, capable, curious? What if they built something, changed something, left something behind? And what if time, slow, relentless time, took it all away? We're used to looking for ruins, walls, tools, bones, but those don't last. Not really. Wood rots, metal rusts, stone erodes, even fossils out. Most trusted time capsules are rare. To fossilize, an organism must be buried quickly, protected from scavengers, preserved by minerals. And even then, it must survive pressure, heat, and erosion. Then it must be found. Most life leaves no fossil. Most history leaves no monument. So what does last? Not the structure, but the shift. Not the artifact, but the anomaly. When a civilization burns fuel, it changes the air. When it mines metal, it changes the soil. When it farms, it changes the land. These changes, chemical, ecological, planetary, can be written into the earth itself, not as sentences but as signals. Carbon ratios, isotope spikes, unnatural compounds. They don't tell a story, but they to whisper that something happened. And that whisper, if it's loud enough, wide enough, strange enough, might survive. So maybe the question isn't did someone come before, maybe it's would we know if they had. Let's think about scale. Humans have reshaped the planet in just a few centuries. We've altered the atmosphere. We've filled oceans with plastic. We've left radioactive traces in the soil. If we vanish tomorrow, some of those signals would linger, not forever, but long enough to be noticed, long enough to be questioned. Now imagine a civilization that lived not thousands, but millions of years ago. Would its signals survive? Would they be buried, distorted, mistaken for natural change? Would we find them? Would we recognize them? Or would they be filed away as unexplained anomalies? This is where the question deepens, because the earth doesn't preserve evenly. It forgets, it edits, it rewrites. Mountains crumble, seafloors sink, rivers change course, entire regions disappear, and what remains is patchwork, fragment, clue. So if we want to ask whether someone came before, we need to learn how the earth speaks, not in words but in chemistry, in sediment, in silence. We need to listen not for monuments but for disruptions, not for stories but for scars. And we need to accept that most of whatever happened here is gone, not hidden, just undone. Still some things linger, a shift in carbon, a layer of ash, a trace of something synthetic. They don't prove anything, but they suggest. And suggestion, in deep time, is the beginning of wonder. So tonight, we're not chasing proof. We're following possibility. We're asking what the earth might still remember and what it might have already forgotten. We're asking not whether we're alone in the universe, but whether we've ever truly been alone on this planet. And we're doing it slowly, gently, one layer at a time. Let's imagine the earth as a storyteller, not one who speaks in words, but one who writes in layers. Its stories aren't told in sentences, they're told in sediment, in chemistry, in silence. Most of what we know about the deep past doesn't come from fossils or ruins. It comes from the ground itself, from the quiet accumulation of dust, ash, shells, and minerals. Layer by layer, the planet builds its archive, not deliberately, not with intention, but with patience. Each layer is a moment, a climate, a season, a catastrophe, a shift, and together they form a record, not complete, not perfect, but persistent. This is the language of the earth, and if we want to ask whether someone came before us, we need to learn how to read it. Let's start with sediment. Sediment is the slow rain of the world. It falls in lakes, in oceans, in valleys. It settles in quiet places, where wind and water carry the dust of life. Over time, these particles accumulate, they compress, they harden, they become rock. And in that rock we find clues, not stories, but signals. A sudden layer of ash might mean a volcano erupted. A spike in iridium could suggest an asteroid impact. A change in carbon ratios might point to a shift in the atmosphere. These aren't conclusions, they're questions. They're the Earth's way of saying, something happened here. Now imagine a civilization not ours, but one long gone. If it changed the chemistry of the air, that change might be recorded in ice cores or ocean sediment. If it mined metals, those metals might appear in unusual concentrations in the soil. If it burned fuel, the isotopic signature of that combustion might linger. These are the kinds of traces that don't look like civilization. They look like chemistry, like anomalies, like quiet disruptions. And that's the challenge, because the Earth's language is subtle. It doesn't shout, it doesn't label, it whispers. And those whispers can be hard to interpret. Let's talk about isotopes. Isotopes are versions of elements, same number of protons, different number of neutrons. Carbon has several isotopes. Carbon 12, carbon 13, carbon-14. When we burn fossil fuels, we release carbon that's depleted in carbon 13. That shift can be measured. It's a fingerprint of industrial activity. Now imagine finding a similar shift in a layer of rock that's 100 million years old. Would we recognize it? Would we know what it meant? Or would we assume it was natural? That's the heart of the problem. The Earth has its own vocabulary of change. Volcanoes release carbon, methane seeps, alter chemistry, microbial blooms leave strange residues. So even if we find a signal, we have to ask, was this nature or was this something else? And something else is a bold claim. It requires more than one clue. It requires a pattern, a spike in carbon, a drop in biodiversity, the appearance of synthetic compounds, all in the same layer, all around the world. That's when the whisper becomes a suggestion, and the suggestion becomes a possibility. Let's talk about synthetic materials, plastics, pesticides, industrial chemicals. These don't occur naturally. They're made, they're designed, Some degrade quickly, others persist. Microplastics, for example, are already turning up in ocean sediment, polar snow and mountain soil. They're small, but they're everywhere, and under the right conditions. Buried, oxygen-free, undisturbed, they might last for tens of thousands of years, maybe longer. Now imagine finding a layer of strange polymers in a rock formation from the distant past. Would we know what it was? Would we recognize it as artificial? Or would we call it an unexplained deposit? That's the risk. Not that the signal won't survive, but that we won't understand it, because the Earth's language isn't just subtle, it's ambiguous. A spike in lead might mean mining, or it might mean volcanic activity. A change in nitrogen might mean agriculture, or it might mean a natural shift in ecosystems without context. Without supporting evidence, we're left with questions. And questions, while beautiful, don't always lead to answers. Let's talk about magnetic orientation. As the Earth's magnetic field shifts, minerals and sediment align with it. These shifts are recorded. They form a kind of calendar. By studying the orientation of magnetic particles, we can date layers of rock. We can trace the rhythm of the planet's field. And if a civilization altered that rhythm through energy use, through massive infrastructure, through unknown technologies, those changes might be detectable. But again, we'd need a pattern, a global signal, a disruption that doesn't match known cycles. And even then, we'd be cautious, because science is careful. It prefers the simplest explanation. And civilizations, especially ancient, vanished ones, are not simple explanations. So what do? We listen, we read the layers, we measure the isotopes, we catalog the anomalies, and we remain open, not to fantasy, but to possibility. Because the Earth's archive is incomplete, it's patchy, it's biased. Some environments preserve well, others erase quickly. The ocean floor, for example, is constantly recycled. Old sediment is pulled into the mantle, new sediment forms. Most of the seafloor is younger than 200 million years. That's a blink in geological time. So if a civilization lived near the coast or built on islands, its traces might be gone, not hidden, just erased. Continental interiors preserve better, especially dry regions, caves, deserts, deep lake beds. These are the places where the Earth's memory lingers, and in those places we might find something. Not a monument, not a tool, but a shift, a change in chemistry, a pattern in the soil, a signal that doesn't belong. And that signal, if it's strong enough, strange enough, persistent enough, might be the echo of something lost, something that lived, changed the world, and then disappeared. So tonight we're not just asking whether someone came before, we're asking whether the Earth remembers, whether its layers still hold the imprint of a civilization we've never known, and whether in the quiet language of sediment and isotope, we might one day learn to read it. Let's step out of imagination for a moment, not to abandon it, but to see where science has already begun to ask the same question. Because as strange as it sounds, the idea that a civilization might have existed long before humans is not just a bedtime thought experiment. It's a real scientific inquiry, one with a name and a method. It's called the Silurian hypothesis. The name is borrowed from fiction, a nod to a British science show where intelligent reptiles once ruled the Earth before humans ever arrived. But the hypothesis itself is not about lizards or legends. It's about geology and humility. That it was proposed by two scientists, Gavin Schmidt and Adam Frank, who weren't trying to prove that someone came before us. They were asking a different question. If an industrial civilization had existed millions of years ago, would we be able to detect it? Not through ruins, not through artifacts, but through the chemical and geological signals it might have left behind. It's a question about method, about limits, about what science can see and what it might miss. Let's break it down. Imagine a civilization like ours. It burns fossil fuels. It manufactures synthetic materials. It alters ecosystems. It leaves waste. Now imagine that civilization disappears, not in a dramatic collapse, but slowly, quietly over time. Its cities crumble, its artifacts decay, its bones dissolve, but its impact, its planetary footprint might remain in the atmosphere and the oceans. In the soil, carbon dioxide levels rise, nitrogen cycles shift, plastics accumulate, radioactive isotopes settle. These changes, if widespread and rapid, could be recorded in sediment layers. They could form a thin, strange band in the geological record, and that band, if found millions of years later, might raise questions. What that happened here? Was it natural, or was there something else? That's the heart of the Silurian hypothesis. It doesn't claim that a civilization existed. It asks how we would know if it had. It's a test of our tools, a challenge to our assumptions, because science is good at finding what it expects to find. But what if the signal is unfamiliar? What if the evidence doesn't look like civilization? What if it looks like chemistry? Let's talk about markers. The hypothesis focuses on things that don't vanish easily, things that might survive deep time. One is carbon isotope ratios. Burning fossil fuels releases carbon that's depleted in carbon-13. This shift can be measured. It's already being recorded in modern sediments. If a similar shift appeared in ancient layers without a known natural cause, it might suggest combustion, industry, technology. Another Marker is synthetic compounds, plastics, pesticides, industrial chemicals. Some degrade quickly, others persist under the right conditions. Varied, oxygen-free, undisturbed. They might last for tens of thousands of years, maybe longer, if we found ancient layers with similar compounds not naturally occurring, not explainable by biology or geology. We'd have to ask where they came from. There's also the question of fossil fuel byproducts. Coal ash, fly ash, heavy metals. These accumulate in layers. They're distinct, they're measurable, and they don't occur without combustion. If we found ancient deposits with these signatures, especially in patterns that suggest processing, they might point to industrial activity. But here's the challenge. Many of these markers can also be caused by natural processes. Volcanoes release carbon, methane seeps alter chemistry, asteroid impacts scatter rare elements. So even if we find a signal, we have to ask, was this nature or was this something else? And something else is a bold claim. It requires more than one clue. It requires a pattern, a spike in carbon, a drop in biodiversity, the appearance of synthetic compounds, all in the same layer, all around the world. That's when the whisper becomes a suggestion, and the suggestion becomes a possibility. Let's talk about extinction. Human activity has accelerated extinction rates. Species are disappearing. Ecosystems are collapsing. This kind of biological signature, a sharp drop in biodiversity, can leave a visible mark in the fossil record. If something similar happened in the past without an obvious natural cause, it might hint at an industrial agent. But again, we'd need context, because extinction can be caused by many things: climate change, volcanic eruptions, asteroid impacts. Without supporting evidence, we're left with questions, and questions, while beautiful, don't always lead to answers. That's why the Silurian hypothesis is careful. It doesn't leap to conclusions, it builds a framework. It asks, what kinds of signals would an industrial civilization leave? How long would those signals last? Where would they be found? And how would we distinguish them from natural variation? It's a way of thinking, a way of testing, a way of remaining open. Because science isn't just about what we know, it's about what we're willing to consider. And considering the possibility of a pre-human civilization isn't about fantasy, it's about humility. It's about recognizing that our own impact, our own signal might one day be misread. That, millions of years from now, someone might find a thin layer of plastic, a spike in carbon, a trace of technetium-99, and wonder what happened. Was it a volcano, a bloom, a burst of natural change, or was it us? And if that's true for our civilization, it might also be true for one we've never known. So tonight, we're not just asking whether someone came before, we're asking whether the Earth remembers, whether its layers still hold the imprint of a civilization we've never known, and whether, in the quiet language of sediment and isotope, we might one day learn to read it. Let's imagine a civilization again, not in its prime, but in its fading. Its towers have fallen, its machines have rusted, its language is lost, but its materials, its technologies, might still whisper if we listen carefully, because not everything vanishes. Some things endure, not in their original form but as traces, as ghosts in the rock. This is the lost tech test, a thought experiment, a forensic puzzle, a way to ask what survives, and more importantly, how would we know it was made? Let's begin with the obvious. Stone. Civilizations build with it, carve it, stack it, shape it, but stone erodes, it crumbles, it tumbles into rivers, gets buried by sediment, gets melted by tectonics. Even the pyramids, monuments of endurance, will one day vanish. Give them 10 million years, give them 100, they will be gone. So we look deeper. What about metals? Iron rusts, aluminum oxidizes, copper corrodes, but under the right conditions, buried, dry, shielded, some metals might survive. Not as tools, not as structures, but as flecks, as inclusions in rock. If we found a layer rich in refined metals, not naturally concentrated, not explainable by geology, we'd have to ask, was this mined? Was this made? But even that is hard, because nature is clever. It concentrates metals, too, through hydrothermal vents, through volcanic processes, through time. So we need more, we need patterns. Let's talk about alloys. Some combinations of metals don't occur naturally. Stainless steel, bronze, titanium, aluminum blends. If we found these, especially in structured forms, we'd have stronger evidence. But again, time is cruel. Even alloys degrade. They fracture. They oxidize. And after millions of years, they may be indistinguishable from natural mineral clusters. So we look elsewhere. What about ceramics? Ceramics are durable. They resist heat. They resist corrosion. Some ancient pottery has survived for thousands of years. Some glazes contain compounds that don't occur in nature. If we found ceramic fragments, especially with complex compositions, they might suggest technology, but ceramics are brittle. They shatter. They scatter. And without context, a shard is just a rock. So we ask a harder question. What about synthetic materials? Plastics, polymers, composites. These are modern. They don't occur naturally. They're made through chemistry. Some degrade quickly. Others persist. Polyethylene, polystyrene, Teflon. Under the right conditions, buried in anaerobic sediment, shielded from sunlight, they might last for tens of thousands of years. maybe longer, but millions. That's uncertain still. If we found a layer with synthetic polymers, especially ones with no biological origin, we'd have to ask, who made this, and when? Let's talk about isotopes. Some technologies leave radioactive traces: nuclear reactors, medical imaging, industrial processes. These produce isotopes that don't occur naturally or occur only in trace amounts. Technetium-99, plutonium-244, curium-247. These have half-lives that span thousands to millions of years. If we found them in ancient layers, especially in concentrations, they'd be hard to explain. They'd suggest processing, refinement, technology. But again, we need caution, because some isotopes can be produced by natural fission, by cosmic rays, by rare geological events, so we need a suite of evidence. Not just one clue, but many. Let's talk about geometry. Nature is chaotic. It builds in curves, in fractals, in randomness. Technology often builds in order, in symmetry, in repetition. If we found structures, not just materials but shapes, that suggest design, we'd have stronger evidence. A grid of holes, a lattice of rods, a repeating pattern in stone. But even here, nature surprises us. Crystal lattice, basalt columns, honeycomb caves. They look artificial, but they're not so. Geometry alone is not enough. Let's talk about context, because the strongest evidence comes not from a single artifact, but from a pattern, a layer of synthetic compounds, a spike in carbon isotopes, a drop in biodiversity, a cluster of refined metals, all in the same place, all at the same time. That's when the whisper becomes a voice, and the voice says, something happened here, something unusual, something that doesn't fit. But even then we must be careful, because science is not about certainty, it's about probability, and the probability of misreading nature is always present. So we ask, what would make the case stronger? A fossil, not of a creature, but of a tool, a gear, a circuit, a fragment of a machine, preserved in stone, encased in sediment. That would be extraordinary. But it's also unlikely, because most tools decay, most machines disintegrate, and fossilization is rare. So we return to the test, the lost tech test. It's not about finding a phone in a fossil. It's about asking, what kinds of technology leave traces? How long do those traces last? And how do we distinguish them from nature? It's a way of thinking, a way of remaining open, a way of listening to the earth with humility, because maybe the signal is there, faint, buried, waiting, and maybe, just maybe, we'll learn to hear it. Let's talk about time. Not the kind we measure in hours or years, but the deep kind, the kind that flows beneath our feet, layer by layer, epoch by epoch. Geological time. It's vast, it's slow, it's deceptive, and it plays tricks on our imagination, because when we look at the Earth's history we see it compressed, flattened, reduced to bands of rock and fossil. A billion years becomes a bookshelf, each shelf a period, each page a million years. And in that compression, civilizations, if they existed, become whispers. Let's explore why. Imagine a civilization like ours. It lasts for 10,000 years. From first fire to final satellite. That's a long time for us. Longer than recorded history, longer than agriculture, longer than most languages. But in geological terms, it's a blink. The Earth is 4.5 billion years old. 10,000 years is 0.0002% of that. It's less than a grain of sand in a desert of time. Now imagine that civilization leaves a mark, a layer of sediment, a spike in carbon, a trace of plastic. That layer might be a few centimeters thick, maybe less, and over millions of years it gets buried, distorted, eroded, subducted. It becomes part of the rock, part of the record, but it's thin, it's fragile, it's easy to miss. That's the time compression trap. The idea that civilizations, no matter how grand, might leave only the faintest trace in the geological archive, and that trace might look like a natural anomaly, a brief warming, a sudden extinction, a chemical shift. Unless we know what to look for, we might never recognize it. Let's talk about resolution. Geologists study layers. They drill cores. They analyze sediments, but those layers are not evenly spaced. Some represent thousands of years, others represent millions. And some, due to erosion, tectonics, or lack of deposition, are missing entirely. They're called unconformities, gaps in the record, places where time vanished. If a civilization lived during one of those gaps, its entire existence might be lost, not because it left no trace, but because the trace was never preserved. That's the trap. Even if a civilization lasted for tens of thousands of years, its geological footprint might be smaller than a single volcanic eruption. And if we're not looking carefully, we might never see it. Let's talk about bias. Our understanding of Earth's history is shaped by what we find, and what we find is shaped by where we look. Most geological studies focus on accessible sites, places with exposed strata, places with known fossils. But the Earth is vast. Oceans cover 70% of its surface. Many regions are unexplored. Many layers are buried deep. If a civilization lived in a place that's now underwater, or buried beneath kilometers of sediment, we might never find it. And even if we did, we might not recognize it because our expectations shape our interpretations. We expect to find nature, so we explain anomalies as natural. We expect to find biology, so we overlook technology. That's the trap, not just of time, but of thought. Let's talk about preservation. Not all materials fossilize. Not all structures endure with decays. Metal corrodes, glass shatters, even stone can be ground to dust. And fossilization requires specific conditions: rapid burial, low oxygen, stable chemistry. Most artifacts don't get those conditions. Most vanish. So even if a civilization left behind cities, tools, art, they might all be gone. And what remains might be chemical, isotopic, subtle. Let's talk about scale. We think of civilization as vast, global, transformative, but what if it wasn't? What if a pre-human civilization was small, localized, brief? A few million people, a few thousand years, a few regions. Its impact might be real, but its footprint might be faint. And in the vastness of geological time, it might be indistinguishable from natural variation. That's the trap, the assumption that scale equals visibility. But sometimes the most profound things leave the quietest marks. Let's talk about comparison. We look at our own civilization and imagine its legacy. Skyscrapers, satellites, synthetic compounds. Surely these will endure, but will they? Most buildings will crumble, most satellites will fall, most plastics will degrade, and even our most durable materials might be lost to erosion, subduction, recycling by the planet itself. So if we imagine a past civilization, we must ask, would its legacy be stronger than ours or weaker? And if ours might vanish, so might theirs. That's the trap, the illusion of permanence. Let's talk about humility, because of the time compression trap is not just a scientific challenge, it's a philosophical one. It reminds us that even the grandest human achievements are temporary, that even the most advanced technologies are vulnerable, that even the most enduring stories can be lost. And it invites us to see civilization, not as a monument, but as a moment, a brief flare in the long twilight of Earth. Let's talk about wonder, because even if we never find evidence of a pre-human civilization, the possibility itself is beautiful. It expands our imagination, it deepens our curiosity, it humbles our assumptions, and it reminds us that the Earth is old, older than memory, older than myth. And in that age, there may have been others, brief, bright, forgotten, but not impossible. So tonight, as we drift into sleep, we carry this thought that time is vast, that history is fragile, and that the Earth may hold secrets we've only begun to ask. Asterisk. Let's begin with a simple truth. Most things that live do not become fossils. They vanish, they rot, they dissolve into the soil or drift into the sea. Fossilization is not the rule, it's the exception. A rare alignment of chance and chemistry, and that rarity shapes everything we know about the past. It's called the fossilization lottery, and tonight, we're buying a ticket. Let's explore the odds. For a creature to fossilize, it must die in the right place: a riverbed, a lake bottom, a quiet sea. It must be buried quickly, shielded from scavengers, protected from oxygen. Then it must survive pressure, heat, time. And finally, it must be found, lifted from the rock, recognized, preserved. Each step is a filter. Each filter removes 1,000 possibilities, and only a few make it through. That's why the fossil record is patchy, why entire ecosystems are missing, why soft-bodied creatures are almost invisible, and why civilizations, if they existed, might be too. Let's talk about materials. Bones fossilize, shells fossilize, teeth fossilize. But what about tools, buildings, books? Most are made of wood, metal, fiber, clay. These decay, they shatter. Even stone tools can be ground to dust by glaciers, rivers, tectonics, and unless they're buried quickly, they're lost. So the odds of a tool fossilizing are low. The odds of a structure fossilizing are lower, and the odds of a structure fossilizing are lower, and the odds of an entire civilization leaving a fossilized trace are vanishingly small. Let's talk about bias. The fossil record favors the durable, the common, the lucky. It favors creatures with hard parts, environments with rapid burial, regions with stable geology. It favors the ocean, the swamp, the floodplain. It does not favor cities, mountaintops, deserts. So even if a civilization flourished on high ground, in dry climates, on islands now lost, its remains might never fossilize, and even if they did, they might never be found. Let's talk about scale. We imagine fossils as abundant, but they're not. Most species leave no trace. Most individuals vanish. Even dinosaurs, giants of the past, are known from fragments: a tooth, a femur, a partial skull. Entire species are reconstructed from a handful of bones. So if a civilization left behind a few tools, a few structures, a few artifacts, they might be missed or misinterpreted or dismissed as natural. That's the lottery. Let's talk about context. Because fossils don't speak alone. They need surroundings, layers, patterns. A single artifact without context is a mystery. A shard of ceramic in a layer of volcanic ash might be volcanic glass. A piece of metal in a coal seam might be a mineral inclusion. Without context, we hesitate. And hesitation can erase history. Let's talk about discovery. Because even if something fossilizes, even if it survives, even if it's preserved, it must still be found, and most of the Earth is unexplored. Deep oceans, remote mountains, buried basins. We've only scratched the surface, and the surface is where erosion happens, where fossils are lost. So the odds of finding a fossilized trace of civilization are slim, not impossible, but slim. Let's talk about misinterpretation, because even when we find something strange, we explain it with what we know. A pattern in stone might be a natural fracture, a cluster of metal might be a geochemical anomaly, a buried structure might be a root cast. We err on the side of nature, because nature is vast and civilization so far is small. But what if we're wrong? What if some anomalies are not natural? What if some fossils are not biological? What if some traces are not chance? That's the question. Let's talk about humility, because the fossilization lottery reminds us that absence of evidence is not evidence of absence. It reminds us that the past is filtered through chance, and that chance is not always kind. It reminds us that even the most advanced societies might vanish without a trace, and that our own legacy might be just as fragile. Let's talk about wonder. Because the lottery is not just about odds, it's about possibility. The possibility that something survived, that something was preserved, that something waits to be found, and that, when it is, we'll listen, we'll ask, we'll wonder, we'll imagine. So tonight, as we drift into sleep, we carry this thought, that the Earth is old, that its memory is imperfect, and that somewhere, beneath layers of time, a trace may remain, a fossil, a fragment, a whisper, waiting. Let's imagine the Earth as a canvas, painted not with colors but with chemistry, with climate, with life. Each layer a brushstroke, each epoch a palette, each event a signature. Volcanoes leave ash, asteroids leave iridium, ice ages leave isotopes, and civilizations, if they exist, leave something too. A signature, not of shape, not of sound, but of change. Let's explore what that change might look like. Because a civilization, especially an industrial one, doesn't just build, it transforms, it alters the atmosphere, it shifts the oceans, it modifies the land, and those modifications can be measured. Let's begin with carbon. Burning fossil fuels releases carbon dioxide, lots of it. That carbon has a distinct isotopic fingerprint. It's depleted in carbon-13, and when released in large amounts, it shifts the global ratio. That shift is already happening. It's measurable. It's recorded in sediments. If a similar shift appeared in ancient layers without a natural cause, it might suggest combustion, industry, civilization. Let's talk about nitrogen. Modern agriculture uses synthetic fertilizers. These alter the nitrogen cycle. They increase reactive nitrogen in soils, rivers, oceans. That increase can lead to dead zones, algal blooms, the ecosystem collapse, and it leaves a chemical trace. If we found ancient layers with similar nitrogen anomalies, especially alongside other signals, we'd have to ask, was this natural or was it managed? Let's talk about plastics. They're everywhere, in oceans, in soils, in the air. Some degrade, some persist. Microplastics are now found in remote mountains, deep trenches, polar ice. They're becoming part of the sediment, and if they persist long enough, they may fossilize. If we found ancient layers with synthetic polymers, especially ones with no biological origin, we'd have a strong clue. Let's talk about metals. Industrial processes release heavy metals, lead, mercury, cadmium. These accumulate in sediments. They're toxic. They're traceable. If we found ancient layers with unusual metal concentrations, especially in patterns, they might suggest technology. Let's talk about isotopes. Nuclear activity produces isotopes that don't occur naturally or occur only in trace amounts. TECHNETIUM-99, plutonium-244, iodine-129. These have long half. They're distinct. They're measurable. If we found them in ancient layers, especially in concentrations, they'd be hard to explain. They'd suggest refinement, processing, civilization. Let's talk about extinction. Civilizations change. Ecosystems, they introduce species. They eliminate others. Modern extinction rates are far above background levels. This kind of biological disruption leaves a mark. A sudden drop in biodiversity, a shift in species composition, a change in fossil patterns. If we found ancient layers with similar disruptions, especially alongside chemical signals, we'd have to ask, was this natural or was it engineered? Let's talk about sedimentation. Civilizations move earth. They build dams, they mine, they pave. These activities alter erosion. They change sediment flow. They reshape landscapes, and those changes can be recorded. If we found ancient layers with unusual sedimentation, especially rapid deposition, it might suggest construction, modification, civilization. Let's talk about temperature. Industrial activity warms the planet. Greenhouse gases trap heat. Climate shifts. These shifts are measurable in ice cores, in tree rings, in ocean sediments. If we found ancient warming events with no volcanic or orbital cores, especially rapid ones, they might suggest artificial forcing. Let's talk about synthesis. Because no single signal is enough. Carbon shifts can be natural. Metal concentrations can be volcanic. Extinctions can be climatic. But when signals align, when they cluster, when they form a pattern, we begin to see a signature, a civilization signature. Let's imagine that signature, a thin layer in the rock, rich in synthetic compounds spiked with heavy metals, marked by isotopic anomalies, accompanied by a drop in biodiversity, a shift in sedimentation, a warming trend, all within a narrow time band all around the globe. That's not nature. That's not chance. That's a footprint. Let's talk about comparison, because we can compare that footprint to our own, the Anthropocene, proposed epoch defined by human impact. It's already forming in sediments, in chemistry, in biology, and if we vanish tomorrow, it would remain a thin layer, a strange band, a whisper of civilization. So if we can recognize our own signature, we can look for others not identical, but similar, not modern, but artificial. Let's talk about humility, because the civilization signature reminds us that we are not the first to change the planet, and perhaps not the last. It reminds us that the Earth records our presence not in monuments, but in molecules, and that those molecules may be all that remains. Let's talk about wonder. Because the search for a signature is not just scientific, it's poetic. It asks, what does it mean to leave a mark? What does it mean to be remembered? What does it mean to be seen? And it invites us to imagine others. Civilizations lost, footprints buried, stories erased, but not forgotten. So tonight, as we drift into sleep, we carry this thought that the Earth is a canvas, that civilizations are brushstrokes, and that somewhere, beneath layers of time, a signature may remain, waiting to be read. Asterisk, we've searched the layers, we've sifted the sediments, we've listened for whispers in the language of isotopes and fossils, and still the Earth is quiet. No gears, no scripts, no unmistakable signs, just stone, just chemistry, just the slow breath of time. It's tempting to take that silence as an answer. To say, there was nothing. There was no one. We are the first, but silence is not the same as absence, and tonight we explore that difference. Let's begin with erosion. The Earth is not static. It moves, it grinds, it recycles. Mountains rise and fall. Rivers carve and carry. Winds scour and smooth. Even the hardest materials are worn down. And over millions of years, entire landscapes vanish. Cities built on stone can be ground to sand. Monuments carved in cliffs can be lost to frost and rain. So the silence of the stones may be the silence of forgetting. Let's talk about subduction. The Earth's crust is restless. It slides, it sinks, it melts. Tectonic plates dive beneath one another, carrying sediments into the mantle. Everything buried, fossils, artifacts, signals can be destroyed, turned to magma, erased, and the deeper the time, the greater the risk. So, the silence of the stones may be the silence of fire. Let's talk about selectivity. The fossil record is biased. It favors the durable, the common, the lucky. It misses the soft, the rare, the brief. Civilizations, especially small ones, may leave traces too delicate to survive. Wooden tools, organic fabrics, biodegradable structures, even advanced materials, may degrade beyond recognition, so the silence of the stones may be the silence of fragility. Let's talk about misinterpretation, because even when we find something strange, we explain it with what we know. A pattern in rock might be a natural fracture. A cluster of metals might be a geochemical oddity. We err on the side of nature, because nature is vast, and civilization so far is rare. But what if some anomalies are not natural? What if some silences are misread? Asterisk, so the silence of the stones may be the silence of caution. Let's talk about gaps. The geological record is incomplete. There are unconformities, missing layers, missing time. Entire epochs may be gone, and if a civilization lived during one of those gaps, its story may be lost, not because it left no mark, but because the mark was never preserved. So the silence of the stones may be the silence of missing pages. Let's talk about humility, because silence is not a verdict. It's a condition. It reminds us that our tools are limited, that our knowledge is partial, that our expectations shape our vision, and it invites us to listen more deeply, to ask better questions, to remain open. Let's talk about presence, because even in silence there is presence. The Earth is full of signals, carbon shifts, metal traces, extinction events. Some are natural, some are ambiguous, some are unexplained. And in those unexplained moments we find possibility, not proof, but wonder. Let's talk about time, because silence may not be permanent. New discoveries emerge, new methods evolve, new questions are asked. What is silent today may speak tomorrow. A fossil misclassified, a layer reanalyzed, a signal reinterpreted. So the silence of the stones may be the silence before revelation. Let's talk about meaning, because silence itself can be a message. It can say, look deeper, think wider, imagine more. It can say, the past is not closed, the story is not finished, the Earth still holds secrets. And it can say, even if no one came before, the possibility matters. It expands our view, it deepens our humility, it enriches our sense of time. Let's talk about wonder. Because wonder does not require answers. It thrives in questions, in mysteries, in silences, and the silence of the stones is full of wonder. It invites us to imagine, to explore, to dream. So, tonight, as we drift into sleep, we carry this thought that the earth is quiet, but not empty, that its silence is not a dismissal, but an invitation, and that somewhere beneath layers of time, a story may still wait to be heard. Asterisk, let's leave the land for a moment. Its stones are silent, its mountains forget. Let's go where memory flows. To the oceans, to the lakes, to the quiet basins where sediment settles like sleep. Because if the earth has a diary, it is written in water. Let's explore why. Water moves. It carries, it dissolves, it deposits, that gathers the dust of continents, the ash of volcanoes, the bones of creatures, and it lays them down layer by layer, year by year. In the deep. These layers called varves are delicate, precise, seasonal. They record floods, droughts, storms, spills, and sometimes they record civilization. Let's begin with chemistry. Water absorbs what we release. Carbon dioxide, nitrogen compounds, heavy metals, plastics. These enter rivers, flow to seas, sink to the bottom, and once buried, they can persist. If a civilization altered the chemistry of water through industry, agriculture, waste, those changes might be preserved. Not in monuments, but in molecules. Let's talk about isotopes. Water reflects the atmosphere. Changes in temperature, in carbon levels, in oxygen ratios, all leave isotopic fingerprints. These are recorded in shells, in sediments and ice. And they tell stories. Of warming, of acidification, of disruption. If a civilization caused such changes, the water would remember. Let's talk about microplastics. They're everywhere now, in fish, in plankton, in snow. They sink, they settle, they accumulate, and in the deep ocean where oxygen is low and disturbance is rare, they may fossilize. If we found ancient layers with similar particles, especially synthetic ones, we'd have to ask, who made these? And when let's talk about sedimentation. Civilizations move earth, they deforest, they mine, they build. These actions increase erosion, they send silt downstream, they cloud the water. And that silt settles. If we found ancient layers with sudden increases in sediment, especially fine, uniform grains, it might suggest land use, construction, civilization. Let's talk about biota. Water holds life, and life responds to change. Algal blooms, dead zones, species shifts. These are signs of stress, often caused by nutrient overload, often linked to human activity. If we found ancient layers with similar biological disruptions, especially abrupt ones, they might suggest management or mismanagement. Let's talk about preservation. Water is gentle, it buries softly, it shields from oxygen, it slows decay. That's why many fossils come from aquatic environments, fish, shells, plants. And sometimes artifacts, wooden tools, textiles, even footprints. If a civilization lived near water or used it extensively, its traces might survive. Let's talk about anoxic basins. These are places where oxygen is absent, where decay halts, where preservation thrives. The Black Sea, the Cariaco Basin, the deep Arctic sediments here are pristine, undisturbed, layered like tree rings. If a civilization's waste entered these waters, it might be recorded with stunning clarity. Let's talk about ocean cores. Scientists drill into the seabed. They extract cylinders of mud, each centimeter a century, each layer a line of history. These cores reveal climate, volcanism, extinction, and sometimes anomalies, spikes in metals, shifts in isotopes, fragments of plastic. If similar anomalies were found in ancient cores, they might suggest civilization. Let's talk about silence, because even in water the record is incomplete. Currents disturb, bioturbation mixes, subduction erases, and many basins remain unexplored. So the memory of water is vast but not perfect. Let's talk about humility, because water remembers what we forget. It holds the traces we didn't mean to leave. It archives our impact without judgment. And it reminds us that civilization is not just what we build, but what we change. Let's talk about wonder, because the idea that water holds memory is beautiful. It means the earth listens. It means the planet keeps a diary. It means our actions are written in the currents. And it means that if others came before, their stories may still be there, buried in mud, preserved in silence, waiting. So tonight, as we drift into sleep, we carry this thought that the earth is fluid, that its memory flows, and that somewhere beneath the waves, a trace may remain, a signature, a signal, a story, written in water. Asterisk, we've searched the stones, we've listened to the oceans, we've traced the isotopes, the plastics, the patterns, and still no proof, no artifact, no inscription, no undeniable sign that someone came before. Just questions, just possibilities, just the quiet hum of wonder. This is the paradox of evidence, the idea that absence can be both a barrier and an invitation. Let's explore it gently. Science is built on evidence, on data, on repeatable observation. It asks, what can we measure? What can we test? What can we know? And when evidence is lacking, science hesitates. It does not leap. It does not assume, it waits. But imagination, especially informed imagination, asks something different. It asks, what might be true? What might we be missing? What might we not yet know how to see? And in that space, the paradox blooms. Let's talk about thresholds. Evidence has thresholds. A signal must be strong, a pattern must be clear, a cause must be distinguishable, but deep time blurs those thresholds. It erodes signals, it scatters patterns, it mixes causes. So even if a civilization left a trace, that trace may fall below the threshold not because it's absent, but because it's faint. Let's talk about ambiguity. Many geological signals have multiple explanations. Carbon spikes can be volcanic, metal concentrations can be natural, extinctions can be climatic. So even when we find anomalies, we hesitate. We ask, is this artificial or is it nature being strange? And without context, we lean toward nature because nature has precedent. Civilization, humans does not. That's the paradox. Let's talk about expectation. We expect civilization to leave monuments, tools, scripts, but what if it didn't? What if it was small, ephemeral, biodegradable? What if its legacy was chemical, not architectural? Then our expectations might blind us. We might overlook the signal because it doesn't look like civilization. That's the paradox. Let's talk about interpretation. Because evidence is not just found, it's read, and reading requires frameworks. Assumptions, language, that if our framework says civilization began with humans, then anything older is interpreted differently. A pattern becomes geology, a structure becomes biology, a signal becomes noise. But if we shift the framework, if we allow for the possibility, then the same evidence may speak differently. That's the paradox. Let's talk about humility because the absence of proof is not proof of absence. It's a reminder that our tools are limited, that our vision is shaped, that our knowledge is partial. And it invites us to remain open, to listen more deeply, to ask more gently, to wonder more bravely. Let's talk about legacy because sometimes the search itself is the legacy. The act of asking is a kind of evidence. It shows that we are curious, that we are humble, that we are willing to imagine without certainty. And that willingness may be the most important mark we leave behind. Let's talk about wonder. Because wonder does not require proof. It thrives in mystery, in silence, in possibility, and the paradox of evidence is full of wonder. It asks us to think beyond the obvious, to see beyond the visible, to imagine beyond the known. And it reminds us that the earth is vast, that time is deep, and that stories may still be hidden. So tonight, as we drift into sleep, we carry this thought that the absence of proof is not the end of the story. It is the beginning of inquiry. And that somewhere, beneath layers of time, a signal may remain, faint, ambiguous, beautiful, waiting to be seen by eyes willing to wonder. Let's turn the lens around. We've spent this journey asking whether someone came before. Now we ask, what will they see when they look back at us? Because we are leaving a mark, a bold one, a global one, and that mark is called the anthropocene. It's not yet an official epoch, but it's forming, layer by layer, signal by signal. Let's explore what it looks like. We've changed the atmosphere. Carbon dioxide levels have soared, methane has spiked, ozone has thinned and healed. These changes are measurable. They're recorded in ice cores, in tree rings, in sediments, and they will persist. We've changed the oceans, acidification, warming, plastic pollution. Microplastics now drift in every sea. Synthetic compounds settle in every basin. Dead zones bloom where life once thrived. These changes are layered, preserved, archived. We've changed the land. Deforestation, urbanization, mining. We've moved more earth than all natural processes combined. We've built cities, roads, dams, and those structures, even when they crumble, leave traces. We've changed biology. Species have vanished. Others have spread unnaturally. We've domesticated, engineered, disrupted, and those changes are visible in the fossil record. We've changed chemistry. Heavy metals, radioactive isotopes, synthetic molecules. Some will decay, some will persist, some may be found millions of years from now. Let's talk about legacy because the Anthropocene is not just a geological layer. It's a mirror. It shows us what civilization looks like from the outside. It shows us how our actions become signals, and it invites us to imagine how we'll be read. Let's imagine a future geologist. Not human, not necessarily even biological, just curious, just capable, just wondering. They drill a core, they find a layer. It's thin, it's strange. Carbon spikes, plastic fragments, metal traces, isotopic anomalies. They ask, what happened here? Was it a bloom, a burst, a civilization? They analyze, they debate, they wonder, and maybe, just maybe, they recognize us not by our monuments, not by our machines, but by our impact, by the way we changed the planet, by the way we left a signal. Let's talk about humility, because the mirror of Anthropocene reminds us that we are not separate from nature. We are part of the record, part of the archive, part of the story, and that story may be read long after we're gone. Let's talk about wonder, because the idea that someone might study us as we've studied the past is beautiful. It means we're connected, across time, across species, across civilizations. It means our actions matter, not just now, but always so, tonight. As we drift into sleep, we carry this thought that we are writing a chapter in the Earth's diary, and that chapter may be read by eyes we'll never know. We've wandered through deep time. We've asked impossible questions. We've imagined forgotten worlds and silent signals. And now we return, not with answers, but with perspective. Because the Earth is old, older than memory, older than myth. And in its layers, there may be stories we've never heard. Civilizations lost, traces buried, signals faint, or maybe there was no one. Maybe we are the first, the only, the beginning. But even that is a kind of wonder, because it means we are writing the first chapter, and how we write it matters. We've learned that evidence is fragile, that fossilization is rare, that time compresses and erases. We've learned that silence is not the same as absence. And we've learned that the search itself is a kind of legacy. So tonight, as the stars drift overhead, as the Earth turns quietly beneath us, we rest in the beauty of the question, not the answer, not the proof, but the question. Did someone come before? We may never know, but in asking we become part of the story. We become the ones who wondered, who listened, who imagined, and that, perhaps, is the most human thing of all. Good night, traveler of time. Sleep well beneath the ancient sky.